when creating
I'm sorry.
surfaces.
So I will leave you guys.
Yeah.
So
Okay.
I have to go to the university in person now. Okay.
Okay.
Okay. It was very nice
See you, Leo.
talking to you. Yeah.
See you, Leo.
Okay. Thank you. Thank you. Okay. Bye.
Bye.
So there's
Yeah, and happy Thanksgiving.
yeah.
Yeah, happy Thanksgiving. Enjoy your,
Okay.
well, I don't know if you have next week off, but enjoy
No,
Thanksgiving.
we work, but it's yeah. Okay, great. Thank you. Bye.
Right. So there's many ways to make surfaces in Rhino. I'm just going to show you one. So this tutorial, we're going to discuss a little bit about rebuilding and how we can adjust control points and degrees of a curve and surface. And I'll talk about what that means in a bit. So we can create a surface through two planar views. So what I'm going to do here is I have myself two curves, one that was created in the XY plane and one that was created in the XZ plane. And this is a great way to start off making curves, just knowing how your object is going to look in its orthographic views. So if I go to my 4 viewports, you'll see that I created this curve just as a through the curve option as my profile for the seat. So this is the back of the seat, part, and then the leg. And then in top view, I created the profile of it from above. So it's kind of like an ellipse or a circle. And what this first command will do, curve to view, it will basically merge these two curves so that you have one curve that is consistent with this profile in this view and this profile in another view. So to show you what that looks like, I'll type it in, curve to view. Doesn't really matter which order you select, but now that I've selected the two, it's create this new curve that remains the same profile in the top and the front view. So you have pretty elegant curve now, which has a lot of control points. So you can adjust it now by selecting the control points and moving it around or etc. But right now there's so many that it's such a local change and that it won't retain that border as nicely as if you had fewer control points. So one way we could do that is through our rebuild command. And rebuild is applicable both on curves and on surfaces. So I'll show you what it looks like on a surface. We have this new dialog box which shows us the point counts and the degrees, and that's pretty much what's important in here. In the parentheses is what it is currently. So we have 214 points, and that's quite a lot. And we'll reduce it to something like 3 or 5 right now. And you'll see that it's deformed our profile. It's not picking up the amount of curves. So as much as we want to reduce the amount of point counts, we want to be within a range that is within that tolerance of that original curve. So here you can see yellow is the original and, well, black is the new one, and they're slightly off, which is fine. It's close enough for me, and I could simply select OK. And now we have fewer control points that are more manageable and affect the curve in a less local way and more general. And we could even rebuild this again.
So what
to
is the
further
degrees
reduce.
controlling in that dialog?
Yeah, so the degrees is, I have an exercise for that, or a little bit of a curves, there we go. An explanation for it. So Rhino basically creates its curves mathematically. They all have like their own equations, and if you recall from, what is it, at functions, these are all basically functions that have their own equation that has a certain degree to it. So for example, a straight line, the equation is y equals mx plus b. So you have 1 degree because there's only one x, versus a parabola, which would have an x squared function, x squared plus ax plus b kind of thing, and then continue on to x cubed and x to the 4. And so these basically define how your curves can be affected. So with 1 degree, even though I'll select these curves and type points on, so they're just active without having to select it. So I have 2 control points in this one line. I could select the control point and affect it, and it'll remain a straight line. Similarly, if I select this control point in the middle and move it around, there are 2 straight line segments that have a kink in it, which is our control point. But we could have lines that have 2 degrees. And so what that does, it's I could select this, and instead of a straight line, it's actually a control point that affects the curve of it. So this is a 2-degree curve, which most arcs and circles are as well. So I could affect that, and we'll have 1 control point that affects the curve and the other 2 control points that affect the end of it. And once we have 3 degrees and above, well, you can start playing around with a lot more freedom than with just 1 control point. So, and you'll only be dealing, or most likely be dealing with 1, 2, or 3. Anything above is just more points to adjust that one curve. So I'll create a circle and points on again. And our circle is 2 degrees. So that means if I were to select this control point, it's not gonna be a smooth curve. It's actually gonna have a kink in it. And so if you want to adjust your circle or any curve, basically, so that they don't have these kind of straight line kinks, you'll want it to be a degree 3 or higher. And Rhino allows until degree 11, but I don't think you'll need that. So degree 3, and we'll notice that with the new points, if we were to select it, they'd have their own curvature, which is what I think most times we desire.
Yeah, like unless you wanted something like angling out from specific origin points, like yeah.
So
no,
then
it's actually nice that you can switch between them, because I know I've played around with these in other programs before, and sometimes it's really frustrating the number of degrees that are on it. It's not behaving the way that you want it to. So I like that you can actually change this.
Mm-hmm. So rebuild command, I use it often to change how many control points there are, especially if you're just creating a random curve and then creating a surface, and there's all these points that are unnecessary and just make the, editing of it afterwards a little bit cumbersome. So reducing the amount of control points and ensuring that your curve or surface has at least a degree of 3 is helps the process.
And so rebuild just brings up that window, like that pop.
Yeah. So when we go back to our little curve profile that we used or generated through curve to view, we type rebuild, and it brought up this dialog to change these amount of control points in degrees. So I'll do something like 15. And you can see that it's a little bit off from what it was before.
Yeah, it's basically changing the resolution of the curves.
Yeah, that's a good way to describe it, changing the resolution. So the smaller the point counts is like having a lower resolution or fewer pixels to work with. Mm-hmm. I'll redo this command to show you why we want to keep the amount of control points versus changing them. So I can use my patch command now. That allows me to create a selection of curves that will determine a new surface. So I can select this curve and I'll have this dialog pop up, and what we have are our U-spans and V-spans. So that basically determines our divisions of our surface, and you'll see it by the ISO curves that are placed on it after we generate it. And the second one is the stiffness, which determines how strict the surface will apply to this curve. And so if you want it to be looser, then you would type a higher value. And so I'll show you by the preview that a higher value is going to make a really smooth curve. Like, it doesn't have too many deviations, but it's also outside of the borders, is not adhering well to this curve that we've placed. So if you want as strict as possible, we'll have a value of 1. Having a value of 0 will do some crazy stuff. So I don't know if that's what you want, but go ahead. Okay, we got 1, which is fine, but it's not really following this profile that I've included at the beginning, and that's the whole reason why we did this command, is so that we have a curve that follows this top profile and the side profile. So
yeah, it's more strictly following sort of what the tensions would be on that body, right?
So we can include this curve into our curve selections to apply more of this, apply this curve to that surface. And if we were to rebuild beforehand, so this one is not rebuilt, and this one is rebuilt with fewer control points, we are going to modify this shape so that this line doesn't really fit properly with it. So instead, I want to copy this line and place it in the middle, like how we've created it here. We'll split this curve using this boundary. So what that'll do, it will trim off the ends that aren't really necessary. And so now we've outlined our boundary, but also the profile of the surface that we'd like. And so when I return to my patch command, select all of these and preview our surface, you'll notice that it is more in line with what we want to create based off these profiles. And so there I can now adjust how many divisions I have in my ISO curve. So the more there is, the stricter it'll be to the surface. And it seems like I want less in the V-span and more in the U-span, so that we have this nice natural curve without too many bumps in the middle. So we'll select OK, and now we have a beautiful surface that has subtle curvature also in this y-axis. So this is a really easy way to get a double curvature surface without having to think too much about lofting your curves. You really just need 2 profiles in 2 different views, and that should determine your shape of your surface. So what can we do now? We could also rebuild this surface as well. And even though it's the same command, we'll have a different type of dialog. And just like the rebuild command for the curve, we can adjust the point count and the degrees. So I'll keep these as 3, or I could put them to 2 or 1, and they'll just be more polygonal. So not curved planes, but straight planes. So we'll keep it at 3, and I want to reduce the amount because reducing always smoothens it out slightly. And again, what's in parentheses is what it is currently, and what we're changing is these input boxes. Okay,
Like how it gives you a preview as well.
Yeah, so it's really helpful to take a look at different options before applying the actual execution. So this is
Yeah,
quite
I like how in
nice.
Patch how it actually responds as if it's applying to physical tensions between those surfaces as well. But then when you go to rebuild, it treats the surface as the surface and just sort of maps over top of what you've already made.
Mm-hmm.
It's
Yeah, I
nice
find
having
this.
that ability to flip between those two behaviors, because definitely you want one sometimes and the other at other times.
Mm-hmm. Great. Excuse me. Let's see. Okay, we'll just hide these. We've gone through these first 5. Okay. Now, what can we do with the surface? We could use it sort of like a framework to create more complex geometry on top. So yeah, we could have a surface for our chair, but let's say that it's composed of like wire or thin rods of metal that are crisscrossed so that it has a structure. One way to do this is flow along surface command, which basically takes whatever elements that you have on a surface, like a pattern on a rectangular plane, and then you could switch which surface that those elements are currently on. So I could place those curves that are on a flat plane on top of this surface right here. So I'll show you what that means. I'll create a plane, and it has to be a surface. It can't be like a box of a rectangle of curves. So it has to be a surface, and I'll use the hatch command because the hatch has a lot of different patterns that are already preset, and I don't have to create my own. So one of them is this triangular, or depending on how you look at it, hexagonal pattern. I could also choose like this grid, for example. But I'll choose this hexagonal pattern because it's something more complex that I don't want to create myself. And here at the bottom, we could adjust the rotation and the scale. It could be a bit larger, so I'll say 150. And we'll select OK. So what we have now are 2 objects, one hatch pattern and a surface. And our hatch won't be able to, we can't use it in our flow along surface command, so we'll have to convert it to curve. So you could explode it, and that will release that hatch-like grouping, and we'll create the individual curves. So once we type our flow along surface command, we can select all the objects by left clicking and dragging and deselect our surface. So clicking Control will deselect it, and now all we have selected are our curves. And now that that's done, we'll hit Enter or Space to move on to the next portion. We'll select our base surface, which is this surface right here, and we'll select our target surface. So now this is going to apply this pattern to the form of this surface. And you'll see that it has the curves of our surface now applied, which is, I thought before, like, okay, what's the best way to do this if I wanted to put a pattern onto a weird surface but have it regular, is like to project. But then obviously if you have steep curves like this, then your pattern will be skewed. So this is a way so that your pattern and whatever objects won't be skewed too much. I'm saying too much because this is an irregular surface shape, but this is a rectangle. So some way it's gonna have to match the extents, and not everything's gonna fit onto it perfectly. But I think this is the best way so far to put a pattern of curves onto a surface. And what would be even more accurate is if you knew the dimensions of this curve. the extent of this curve in one direction and then another direction, and try to match this base plane to be roughly the same, so that your pattern here will be approximately consistent with each other when applied.
Now, can you modify the pattern that's been applied to the surface directly? Like, can you?
Yeah, so these are still curves. They're their own individual objects. So what I could do now is, if I hide this, I'd want to trim them to, this border. So one useful command is dupe or dup, and then face border or edge. So there's a bunch of commands under this prefix. Dupe just means duplicate. And so I could duplicate an edge, or in this case, I want to duplicate the border of this surface. So I'll select this, and simply by clicking that, I've duplicated the edge. And these have a lot of control points, which we can rebuild later. But now I could hide this surface and adjust these patterns by trimming them. For example, I'll type trim, and then whatever's intersecting with this boundary line will be cut off. And then I have my chair mesh, and so you would just work on this for a bit so that it's nicely trimmed.
So I guess split wouldn't work on that one.
Pardon?
I guess split wouldn't work in this case.
I think you could split too. It's just you'll select all these lines, deselect the boundary, deselect, not select. Okay, split by this, and slowly just delete whatever isn't within the boundary. So yeah, split also works. I find trim helps like forego that step. You just have to select everything and not one by one.
Mm-hmm.
And yeah, from there you could adjust, you could do whatever with your curves. It's still all editable items. So one thing I could do is I could select these all and put some structure to it or volume by typing pipe, and pipe just takes whatever curve you've selected and adding a circular profile to it. So I could put like a 5mm rods for these, which might be a bit bigger than I wanted, but now I have my pattern as 3D objects as opposed to curves now. And that's more of what we're desiring to achieve, just because it has some real world applications to it. You've got the thickness and you've got the actual structure to it.
Now, is it possible to select that pattern, like the entire pattern, and go to rebuild, like just of that bit that's on the chair, and actually adjust like how many hexagons or triangles that you want? Pattern there directly, or no?
In that case, no. I'd say no, because it's a manual items now. It's not like considered a pattern, but
okay.
What we could do, I'll select the surface, make a copy. Oops, that's not a copy. Surface.
Actually, what did you click there that actually mirrored the change?
So this, I have my gumball snap-on or gumball tool,
Mm-hmm.
and this allows you to use this control tool to either move or scale in one direction. It does so many things, and it's super helpful, but it has a bad rap because it's not as accurate, right? You're moving without a measurement, but you can click it, one of the grips, and place in your movement. So I could do 300 units in that direction. So it's very useful, and I feel like the more you become acquainted with what it could do, the speedier your workflow will be. So what I did was click the control grip on the green arrow, and so this scales in one direction along this axis. And because there's a center point to our object, which is where our gumball is located, it will scale in both directions from that center point. And so if you want it somewhere else, I would select this white little tool, or white circle, left click it, so not right click, but left click, and we could relocate it to somewhere here along the edge. And now you're just defining the axes. And so when I adjust my scale, it's going to not be mirrored because it's at a different location. It's not at the center anymore. And you could scale 1D, and holding shift, you scale 2D, so it's really useful. You can also hold Alt, and when you click, you'll notice that there's a plus sign next to it, so it's going to make a copy. You can also move and make a copy, so that's what I want to do. I'll hold Alt, click that green arrow, and I'll make a copy by dragging it over. We could, I think we could hatch this, can we? Yeah. So we could hatch this surface, but it's a planar thing, so it won't be able to apply. So that's why we do this step first, so that the curves apply to it, but then it's not a hatch anymore. So you'll have to just adjust this hatch in the base plane first, and then create that, execute that command to place it on top, and that will be your back and forth in order to make the changes that you need necessary.
Now, if you're changing your points, like let's say, for example, in this chair, when you're changing one of your edges, is there like a quick command to mirror the change on the other side at the same time, or?
That, I think, points on, we'd have to probably just, I don't know. I would hope so, and I'll look that up. But for now, I would say you just have to mirror the change and know which point is which, and be accurate in how much of a distance you're moving your point. So say -50 for here, and then I'll try to move this 50 because the direction is that way. So good question. I'll look that up, and then I'll probably
Yeah, it's like I was thinking, like,
time.
for example, like when you were pulling some of the points out, like let's say you wanted to create a wing across the top of your chair and you want it to be equal on both sides. If there is a really quick way to just, I'm going to mirror the, or pull this one, I want the one on the opposite side to be the same.
I need to look that up. Okay, and one last thing I guess I'll show you is when you have your surface, we can analyze it a little more properly, I guess. So I'll do another patch command for these curves and make it something reasonably large. Preview that. Okay, nice. We'll drag this over to see the differences between the two. So you'll already notice that this one's a little more bumpy than this surface, but there's this really cool command called zebra. And so it applies this stripe map over top, and how you'll read it is sort of like a topography map or your contours, and it'll show you where there is a little less continuity or smoothness. So this one is really good because you can see there's a lot of stripes that are parallel to each other, and the only real like aberrations are at the center point and at the ends. But you'll notice that with this surface, it's a lot bumpier. We'll have little hills in the middle and at the ends, and if we change our stripe direction from horizontal to vertical, you'll see as well in that direction there's quite a bit of uncontinuity, and here it's quite nice. So this is just a nice analysis tool to observe how your surfaces actually are, because sometimes it could be a little bit deceiving, even though the light is showing where it is contrast to the dark, so that means that there is a bigger change in the surface smoothness. It can be a bit hard sometimes because this looks like perfect, but there is, through our analysis using the zebra command, a little bit of uncontinuity that we could adjust there. So that's a useful command to knowing how and where to apply changes when you're rebuilding and changing your points. So this is a good cause to want to decrease the amount of points. And if we put the points on command, start adjusting our shape. Start adjusting our shapes. Alrighty, so that's a tutorial. Do you have any questions, Amanda?